Now come to the nomenclature. Having learned the classification of halogenated compounds, let us now learn how these are named. The common names of aryl halide are derived by the naming the alkyl group followed by the name of halide. When you write the common name, you have to write alkyl group followed by the name of halide. But in the IUPAC nomenclature, alkyl halides are named as halo-substituted hydrocarbon. For monohalogen substituted derivative of benzene, common and IUPAC names are the same. For dihalogen derivative, prefix ortho, meta, para are used in common system, but in IUPAC system, as you have learned in the class 11, the numerals 12, 13 and 14 are used. Now let's revise the rules of IUPAC nomenclature that you have learned in class 11. In the first step, you have to select the longest carbon chain. Select the longest carbon chain. In the second step, identify the substituents. In third step, number the chain so that functional group gets the lowest possible number. So that functional group gets the lowest possible number. Gets the lowest possible number. Now examine the first example. In the first example, CH3, CH2, CH2, Br. Here the longest carbon chain is 3 carbon long and bromine is bonded to CH2. So when you number it, you have to number it from the right direction. So this will be the first carbon, second carbon and this is the third carbon. As bromine is bonded to first carbon, the name will be 1-bromo. Now write the parent name. Parent is the propane. So the IUPAC name of this molecule will be 1-bromo-propane. Now come to the second example. First of all, select the longest carbon chain. And it also contains 3 carbon long chain. Now number the chain so that the functional group gets the lowest possible number. Here chlorine is the functional group. So when you number from the either direction, it will get 2 numbers. 1, 2 and 3. So here chlorine is bonded to second carbon. That's why you have to write 2-chloro and write the parent carbon chain. As it is 3 carbon long, the name will be propane. Now come to the next example. Here first of all select the longest carbon chain that includes your functional group. So chlorine is the functional group. That's why we have to select this chain which includes your functional group chlorine. Now number the chain so that the functional group gets the lowest possible number. So that's why you have to number it in the right direction. So that's how chlorine gets the first number and this is the methyl substituent. It gets the second number. For halogen we use prefix. As we use prefix for the halogen, first you have to name chlorine before writing the name of substituent. That's why you have to write 1-chloro, 2-methyl and the parent is 3 carbon long. That's why the parent name will be propane. So the complete name of this molecule will be 1-chloro, 2-methyl propane. Now come to the next example. Here bromine is the functional group and it is bonded to the benzene ring. As bromine is the only functional group that is bonded to benzene, that means there is no need to number this benzene ring. You can simply write bromo-benzene. Here also we have used prefix for bromo. That's why we have written bromo before benzene. Now come to the next example. Here it is bi-substituted halogen compound. Here there are two bromine groups which are bonded to benzene ring. As they are in alternate position, in common name you can say it meta. But in IUPAC we do not use ortho, meta or para. Here you have to number this benzene ring. In benzene ring, either you number it in clockwise direction or you can number it in anti-clockwise direction. But you have to select the direction in which both the functional group gets the lowest possible number, or the sum of their number will be the least one. If you number this chain in the anti-clockwise direction, then this bromine will get first number, second, third, fourth and fifth number. So let's draw it. This is benzene. Here this is one bromine and this is another bromine. So if I number in anti-clockwise direction, I have to number it from here 1, 2, 3, 4, 5 and 6. So here bromine will get 1 number and 5 number. So the sum of 1 and 5 will be 6. But when you number it in the clockwise direction, so this bromine will get first, second, third, fourth, fifth and sixth. So in the clockwise direction, they will get 1 and 3 number and the sum will be 4. So that's why we will use to number this molecule in the clockwise direction, and the name of this molecule will be 1,3-dibromobenzene. Similarly, you can name the another molecule. Here there are 3 bromine molecules attached to the benzene ring. In either direction you can number this benzene ring, because in both the direction you will get the same number. So if I number it 1, 2, 3, 4, 5 and 6. So bromine will get 1, 3 and 5 number. So the name of this molecule will be 1,3,5-tribromobenzene. Now let's try to name this molecule. First of all, select the longest carbon chain that contain your functional group. So here again you will get 3 carbon long chain that contain your functional group chlorine. Now identify the substituents. There is one methyl substituent and another methyl substituent. Now number this chain so the functional group gets the lowest possible number. So here we will number it from the right direction 1, 2 and 3. Chlorine gets the first number and both the methyl group get second number. As we have used prefix for the chlorine, you have to write chlorine before the substituents. So here you will get the name 1-chloro-2,2-dimethyl. Parent is 3 carbon long, so the parent name will be propane. Similarly, you can name this molecule. It also 3 carbon long chain and at the second position bromine is bonded. So the name of this molecule will be 2-bromopropane. The dihaloalkanes having the same type of halogen atom are named as alkylidene or alkylene dihalide. The dihalo compounds having both the halogen atoms are further classified as geminal halides or gem dihalide when both the halogen atoms are present on the same carbon. The gem dihalide or geminal dihalide, both the halogen atom present on the same carbon. While in vicinal halide or vis dihalide, halogen atom present on the adjacent carbon atom. So let's examine the example of gem dihalide and vicinal dihalide. This is the example of gem dihalide. Here both the chlorines are bonded to the same carbon atom. While in the vicinal dihalide, both the chlorines are present at the adjacent carbon. They are not bonded to the same carbon. In common name system, gem dihalide are named as alkylidene halide and vis dihalides are named as alkylene dihalide. In the IUPAC name, they are named as dihaloalkanes. So when you see the common name of gem dihalide is named as ethylidene chloride. In the common name system, gem dihalide is named as ethylidene chloride. It is named as ethyl because it contains 2 carbon long chain. That's why the name is ethylidene chloride. While in case of vicinal dihalide, it is named as ethylene dichloride. Ethylene because it has 2 carbons. That's why the name is ethylene. As it is vicinal, that's why we have used ethylene dichloride. Now come to the IUPAC nomenclature. For the IUPAC nomenclature, again you have to select the longest carbon chain and then number the chain. So here it is 2 carbon long chain. When you number it, you will get 1 and 2. Both the chlorines are bonded to first carbon. So the name will be 1,1-dichloroethane. Now come to the second example. Here, this is the longest carbon chain, 2 carbon long, and when you number it, 1 and 2. Both one chlorine will get 1 number and other will get second number. So the name will be 1,2-dichloroethane. Now let's practice these examples. CH3, CH2, CH, Cl, CH3. When you expand this structure, you will get CH3, CH2, CH. Here Cl is bonded to CH and it is bonded with CH3. Now select the longest carbon chain which contain your functional group Cl. So this is the longest carbon chain. Now number the chain so that functional group gets the lowest possible number. So here you have to number this chain from the right direction. 1, 2, 3 and 4. Chlorine gets the second number and the parent is butane. So the name will be 2-chlorobutane. Now come to the next example. Here CH3 whole thrice C CH2Br. So let's expand this structure. So here you will get CH3 C CH3 CH3 and CH2Br. So there are 3 CH3 which are bonded to one C and this C is bonded to CH2Br. Now again select the longest carbon chain that contain your functional group Br. So this is the 3 carbon long chain which contain your functional group Br. Now identify the substituents. So this is methyl substituent and another is also methyl substituent. Now number this chain so that bromine will get the lowest possible number. So again you have to number this chain from the right direction. So 1, 2 and this is 3. So the name of this molecule will be 1-bromo 2,2-dimethyl propane. 1-bromo 2,2-dimethyl propane. Now come to the next example. Here CH3 whole thrice CBr means all CH3 are bonded to this C and this C is bonded to Br. So let's draw the structure. CH3 C CH3 CH3 and Br is bonded to this C. Now select the longest carbon chain that contain your functional group Br. So the longest carbon chain will be this chain that contain the functional group Br. Now identify the substituent. Here methyl is the substituent. Now number this chain so that bromine gets the lowest possible number. So here we can number it from top to bottom 1, 2 and 3. Bromine gets the second number and methyl also gets the second number. As we have used prefix for the halogen, you have to write 2-bromo, 2-methyl, parent is 3 carbon long, so it will be propane. So here you will see the name 2-bromo, 2-methyl propane. Now come to the second example. Here CH2 double bond CHCl. This is the vinyl carbon. This carbon is vinyl carbon because it is sp2 hybridized carbon and chlorine is bonded to vinyl carbon. So the common name will be vinyl chloride, but when you write the IUPAC name will be chloroethene. Here we have used word ethene. Otherwise we have used A and E, but here you have to use E and E as it contains double bond. Now come to the second example. Here CH2 double bond CH2Br. So we need to revise a few rules to name this molecule. First of all, draw the molecule. It is CH2 double bond CH single bond CH2Br. First of all, select the longest carbon chain. So this is the longest carbon chain. Now when we number this molecule, now we need to number this. Now we have to number this chain. When you number this chain, you have to number it in a direction in which double bond gets the lowest possible number. Because double bond or triple bond gets the priority over halogen. So whenever double or triple bonds are there, along with the halogen, you have to give priority to the double or triple bond. That means you have to number double or triple bond least as compared to the halogen. So here you have to number this chain from the left direction. So here it will get 1, 2 and 3. So that's why bromine gets the third number while double bond gets the first number. So when you write the name of this molecule, you will get 3-bromo-propene, or you can write 3-bromo-prop-1-ene. As it is 1-ene, there is no need to write it 1-ene. You can simply write propene. Now come to the next example. Here this is benzene ring and there is one chlorine and one methyl group is bonded. So chlorine is the functional group. So when you number the ring, you have to number in such a way that chlorine gets the lowest possible number. So we will start numbering from chlorine 1 and this is 2. So the name of this molecule will be 1-chloro-2-methyl benzene. Or the other name is also given 2-chlorotoluene because when CH3 group is bonded to benzene ring, it is called as toluene. And if you name it in the form of toluene, first of all write the molecule. Here Cl and here CH3 is there. So as I told you, CH3 bonded to benzene ring is the toluene. So here you have to number from CH3. So here you will get 1 and this is 2. In case of toluene, Cl will get the second number. So when you write the name in the form of toluene, you have to write 2-chlorotoluene. Or when you write it in the form of benzene, you have to number from chlorine. So chlorine will get first number and CH3 will get second number. So the other name will be 1-chloro-2-methyl benzene. Now come to the second example. Here this is benzene. CH2 is bonded to benzene ring and Cl is bonded to that CH2. This is your benzyl chloride. So let's draw the structure. This is benzene ring where alternate single and double bonds are there. It is bonded to CH2 and then it is bonded to Cl. First of all, select the longest carbon chain. So here carbon chain is just one carbon long. Now identify the substituents. So here this is the substituent. When benzene is present as a substituent, it is called as phenyl. Like alkyl, we use for the alkane substituent. Same way we use phenyl for the benzene substituent. Now number this chain. There is no need to number it because chlorine will get only the first number. Now name this molecule. So when you name this molecule, the name of this molecule will be chloro. Now write the name of substituent. This is phenyl. And the name of parent is methane. So the name of this molecule will be chlorophenyl methane. Now come to the next example, CH2Cl2. Here both the chlorines are bonded to the same carbon. So this is the example of gem dihalide. Now let's draw the structure. It is CH2 and chlorine is bonded to this Cl. Another chlorine is also bonded to the same carbon. So this is the example of gem dihalide. There is no need to number the chain as it contains only one carbon. And there are two chlorine, so we will write it dichloromethane. Now come to the next example. Here CHCl3. There are three chlorines bonded to the same carbon. The common name of this molecule is chloroform, or the IUPAC name will be trichloromethane. Similarly, the name of this molecule will be tribromomethane, and this is also called as bromoform. Now CCl4. Four chlorines are bonded to the same carbon. As there are four, you can write tetrachloromethane. Here, first of all, select the longest carbon chain. So it has 3 carbon long chain. When you number it, chlorine will get the first number. So the name of this molecule will be 1,fluoropropane. Now let's solve it. Draw the structure of all the 8 structural isomers that have the molecular formula C5H11Br. Name each isomer according to IUPAC system and classify them as primary, secondary or tertiary bromides. Now let's try to draw the structural isomers of C5H11Br. So first of all, draw the skeletal structure C5. So we need to draw 5 carbons and Br. So I will write here Br. Now balance the hydrogen. So here CH3, CH2, CH2, CH2 and CH2. So this is the first isomer. Now write the IUPAC name of this molecule. First of all, select the longest carbon chain that contains your functional group Br. So it is 5 carbon long chain. And when you number it, bromine will get the first number 1, 2, 3, 4 and 5. So the name of this molecule will be 1-bromopentane. Now identify primary, secondary or tertiary. Carbon to which bromine is bonded to one another alkyl group. This is the big alkyl group which is bonded to the carbon which is bonded to Br. So that's why this carbon is primary carbon. Now draw the second structure. CH3, C, C. First draw the skeletal structure. So there are 5 carbons. Now we can change the position of Br. So here if I write Br at the second position. Now balance the hydrogens. So here CH2, this is CH2, here CH and here CH3. Now select the longest carbon chain. So it is also 5 carbon long chain. Now number this chain. So we can number it from the right direction as we need to give the bromine least number. 2, 3, 4 and 5. So the name of this molecule will be 2-bromo-pentane. Now classify it as primary, secondary or tertiary. The carbon to which bromine is bonded to another alkyl group. This is one alkyl group and this is another alkyl group to which the carbon which is bonded to bromine is bonded. As there are 2 alkyl groups, this carbon is the secondary carbon or the halide is secondary halide. Now draw the another structure of the structure isomer. So again draw the skeletal structure. So there are 5 carbons. Now we can again change the position of Br. So this time I have changed the position of Br to the third place. Now balance the hydrogens. So here CH3, CH2, CH, CH2, CH3. So again longest carbon chain is 5 carbon long, and when you number the chain, you can number this chain in either direction because in both the case bromine will get the third number. So 1, 2, 3, 4 and 5. So the name of this molecule will be 3-bromo-pentane. Now classify it as primary, secondary or tertiary. So here the carbon to which bromine is bonded to this alkyl group, and here there is another alkyl group, secondary halide. Now draw the another structure. First of all draw the skeletal structure. C, C, C. There are 5 C's. So if I again change the position of Br, I will write it here. Now balance the hydrogens. Here CH3, CH, CH2, CH2 and this is CH3. Now select the longest carbon chain. So this is 5 carbon long chain, and when you number this chain, you will number it from the left direction. So 1, 2, 3, 4 and 5. So the name of this molecule will be 2-bromo-pentane. We have already drawn the structure of 2-bromo-pentane. So in one structure and this structure, they both are identical. So this cannot be considered as the structure isomer. So you have to change the molecule. By this changing the position of Br, now we are getting the same molecule. So this time you have to change the structure of the chain. So here C, C. This time I have drawn 4 C's. And if I draw carbon at this position, so when you select the longest carbon chain, you will get the 5 carbon long chain. So that's how you can make the change in the chain. You have to make change in this way. So here when you draw carbon at the second position. So this time I have drawn carbon at the second position and bromine also at the second position. Now balance this hydrogen. Here CH3, CH2, CH3 and this is CH3. Now select the longest carbon chain. So it is 4 carbon long chain to which bromine is bonded. Now identify the substituent. Here this is the methyl substituent. Now number this chain so that bromine gets the lowest possible number. So we will number it from the right direction 1, 2, 3 and 4. Now name this molecule. So the name of this molecule will be 2-bromo, 2-methyl. Parent is 4 carbon long, so the parent name will be butane. Now classify it as primary, secondary and tertiary. When you see the carbon to which bromine is bonded to one alkyl group, this is another alkyl group and this is another alkyl group. So as it is bonded to 3 alkyl groups, this halide is tertiary halide. Let's draw the another structural isomer. So C, single bond C, single bond C and single bond C. So this was our skeletal structure of 5 carbon long. Now again change the position of Br. So this time I have drawn Br over this position. Now balance the hydrogens. CH3, CH, CH, H3 and this is CH3. Now select the longest carbon chain. So here this is 4 carbon long chain. Now number the chain so that bromine gets the lowest possible number. This time you have to number it from the left direction 1, 2, 3 and 4. As bromine gets the second number, the name will be 2-bromo. Substituent is methyl at third position. So you will write 3-methyl. Parent is 4 carbon long, so butane. Now identify the carbon to which bromine is bonded. As this carbon is bonded to one alkyl group and this is another alkyl group to which this carbon is bonded. So this haloalkane is secondary haloalkane as it is bonded to 2 alkyl groups. Now we can change the position of Br. So here you can write CH3, C, single bond C, CH3 is here and this is C. Now we can bond Br to this carbon and now balance the hydrogen. So here you will get CH2, CH, CH2. Now select the longest carbon chain. So this is the longest carbon chain to which functional group Br is bonded. Now number the chain so that the functional group gets the lowest possible number. So here we can number from the right direction 1, 2, 3 and 4. Here methyl is the substituent. Now write the name of this molecule. So here you will get 1-bromo, 2-methyl, butane as the parent is 4 carbon long. Now classify it as primary, secondary or tertiary. So the functional group Br is bonded to this carbon and this carbon is bonded to this bigger alkyl group. So the carbon is primary carbon and this alkyl halide will be primary alkyl halide. Now let's draw the another structural isomer. So this time again we can change the position of Br. So here I can write C, C, C and C. There are 4 carbons and at the second carbon CH3 is there. This time we can change the position of Br to the extreme left corner. Now balance the hydrogen. So here CH2, here again CH2, here is H and here is CH3. Now select the longest carbon chain. So this is the longest carbon chain. When you number the chain, you have to number it from the left direction, as Br is the functional group and it should get the lowest possible number. So 1, 2, 3 and 4. Now write the name of this molecule. So it will be 1-bromo 3-methyl butane. Let's draw the another structure isomer. This time we have to change the carbon skeleton. There are 3 carbons and here is another carbon and this is another carbon. And here we can bond bromine. Now balance the hydrogens. So here CH3, here CH3, here also CH3 and here is CH2. Now select the longest carbon chain. So this is 3 carbon long chain to which bromine is bonded. Now number the chain. So we can number it from the right direction. So here 1, this is 2 and this is 3. So the name of this molecule will be 1-bromo 2,2-dimethyl propane, as the parent is 3 carbon long. Now classify them as primary, secondary and tertiary. Here this is the carbon to which functional group bromine is bonded and to which one bigger alkyl group is bonded. So this carbon is primary carbon and the alkyl halide will be primary alkyl halide. In the same way here bromine is bonded to this carbon and this carbon is bonded to this bigger alkyl group. So this alkyl halide also primary alkyl halide. So let's count how many structure isomers we have drawn so far. So this was 1, 2, 3, 4, this is 5, 6, 7 and this is 8. Now write the IUPAC name of the following molecules. First of all, count the number of carbons. So here carbon is there is also carbon and there is also carbon. Now select the longest carbon chain to which Br is bonded. So here it will start from here, this carbon 1, 2, 3, 4 and this is the 5th carbon to which bromine is bonded. Now number this chain so that double bond and bromine gets the lowest possible number. As we just have learned before, double bond or triple bond gets a priority over halogen. So you have to give the least possible number to the double bond. So that's why you have to start numbering from here. This is 1, 2, 3, 4 and this is 5. At second position double bond is there and at fourth position bromine is there. So the name of this molecule will be 4-bromo pent-2-ene. Now name the second molecule. Again select the longest carbon chain. First of all draw the carbons. This is 1, 2 and 3 carbon. Now select the longest carbon chain. So the longest carbon chain that contain double bond as well will start from here 1, 2, 3 and this is 4. Here there is methyl substituent. but you have to number in such a way that double bond gets the lowest possible number. So here you will number from this direction. So 1, 2, 3 and 4. So bromine is bonded to third carbon, double bond from first carbon, and methyl is bonded to second carbon. So the name of this molecule will be 3-bromo, as we have used prefix for bromo. So that's why we have to write bromine first. So here you will get 3-bromo 2-methyl but 1-ene, as double bond is present at first carbon. Now come to the third example. Here select the longest carbon chain. First of all, count the carbons 1, 2, 3, 4, 5. So that's how you will get 5 carbon long chain, which starts from here 1, 2, 3, 4 and this is 5. Now number this chain. So here this is first, second, third, fourth and fifth. Bromine is bonded to fourth carbon. This is one methyl substituent which is bonded to third carbon, and double bond starts from second carbon. So the name of this molecule will be 4-bromo 3-methyl, parent is 5 carbon long, so pent, and double bond at second carbon, so it will 2-ene. So the name of this molecule will be 4-bromo 3-methyl pent 2-ene. Now name the next molecule. Again select the longest carbon chain that contains your double bond as well as bromine. So here you will get 1, 2, 3 and 4 carbon long chain. Now we need to number the chain. So let's draw the structure here. It is CH3, H. Here is double bond. Here CH3. Here it is bonded to H. This is Br and this is again H. So the longest carbon chain is 1, 2, 3 and 4 carbon long. Now we need to number this chain. So when you number the chain from here 1, 2, 3 and 4. Now note down. So the name you will get the name 4-bromo 3-methyl, parent is 4 carbon long, so but, double bond is at second position, so you will get 2-ene. Now number this chain in the opposite direction. So when you number it from here 1, 2, 3 and 4. So when you name it, you will get 1-bromo 2-methyl but 2-ene. Now check the lowest possible sum. Here 4 plus 3 7 plus 2 9. So here you will get the sum is equal to 9. But when you check the sum in the second option, 1 plus 2 is equal to 3 plus 2 5. So here you will get the lowest possible sum is 5. That's why the second name is the correct name for this molecule. So the name you will get 1-bromo 2-methyl but 2-ene. You always have to check the lowest sum rule. Now come to the fifth example. Here, first of all select the longest carbon chain. This is 1, 2, 3 and 4 carbon long chain. Now when you number this chain, there is no methyl substituent. Just double bond and halogen is there. So you have to number the chain so that double bond gets the lowest possible number. So you have to number it from here 1, 2, 3 and 4. So here bromine gets the fourth number and double bond gets the second number. As double bond gets the second number in either way numbering. So here you have to decide on the basis of lowest sum rule. When you number from top, double bond get the second number and bromine get the fourth number. So the sum comes will be 6. But when you number from the bottom, bromine get the first number and double bond get the second number. Now the sum is 3. So we have to number the chain from the bottom, and the correct name of this molecule will be 1-bromo-but-2-ene. Now come to the next example. Now select the longest carbon chain. So here the chain which include double bond as well as bromine 1, 2, 3. It is 3 carbon long chain that includes your double bond as well as bromine. There is methyl substituent. Now number the chain so that double bond gets the lowest possible number. So 1, 2 and 3. Here bromine get the third number, so the name will be 3-bromo-2-methyl, as the parent is 3 carbon long. So the parent name will be prop, and double bond is at first position. So there is no need to write 1-ene, or even if you can write 1-ene. So the name of this molecule will be 3-bromo-2-methyl-propene, or even you can write prop 1-ene. When your functional group gets the same number as we have discussed in the fourth example. In the fourth example, double bond gets the second number in both the ways. When you number the chain, first of all you have to make it sure that functional group gets the lowest possible number. If there are two ways to number a chain, you have to check whether the functional group gets the lowest possible number in both the ways or not. If your functional group gets the lowest possible number in both the ways, as we have discussed in the fourth example. In fourth example, when you number the chain from top to bottom or bottom to top. In both the ways, double bond gets the lowest possible number, that is 2. But the other substituents gets the different number. In that case, you have to consider the lowest sum rule. Otherwise, you just have to make it sure that the functional group gets the lowest possible number, and you have to number the chain in that way only. Now let's solve this question. Write the structure of the following compounds. So let's draw it. First of all, identify the parent chain. So parent is pentane, that means it is 5 carbon long chain. Methyl is the substituent and chloro is the functional group. So first of all, draw the skeletal structure of parent chain. So parent is 5 carbon long. So first of all, draw the carbon skeleton of 5 carbon long. Now, at the second position, chlorine is there. So we can attach chlorine at the second position. So here, chlorine is there. Now, substituent methyl is at third carbon. So at third carbon, we can draw the substituent. It is CH3. Now balance the hydrogens. So here CH3, CH, CH, CH2 and CH3. So this is the structure of first compound, 2-chloro-3-methyl pentane. So here when you number it from this direction 1, 2, 3, 4 and 5, you will get the name of this molecule as 2-chloro-3-methyl pentane. Now come to the second structure, 1-chloro-4-ethyl cyclohexane. Here cyclohexane is the parent chain. So let's draw the structure of cyclohexane. So this is cyclohexane. 6-membered ring is the cyclohexane. In cyclohexane, there is one chlorine and at 4th position, ethyl substituent is there. So if I write chlorine at this position, so this will be 1st, 2nd, 3rd, and this is 4th position. So at 4th position, ethyl substituent is there, means it is C2H5. So this is the structure of 1-chloro-4-ethyl cyclohexane. Now come to the third structure. 4-tertiary butyl 3-iodoheptane. Heptane is the parent chain. So let's draw the skeletal structure of parent. It is 7 carbon long. C. So there are 4, 5, 6 and 7 carbons. At 4th position, tertiary butyl group is there. At 4th position means this is the center position. When you count in either direction, this carbon will get 4th number. So here tertiary butyl is there. Tertiary butyl means butyl has 4 carbon and the carbon to which substituent is hanging to the parent chain is tertiary. So here this is the tertiary butyl, which is this carbon is bonded to 3 other alkyl group and it is bonded to the carbon main chain. So this is the tertiary butyl group. At 4th position, iodo is there. So here you have to count from either direction. So if we count from this direction, this will be 1, 2, 3, 4, 5, 6 and 7. So at 3rd position, iodo group is there. So iodine is here. Now balance the hydrogens. Here you will get CH3, CH2, CH, C, CH2, CH2 and this is CH3. So this is the structure of 4-tertiary butyl 3-iodoheptane. Now come to the 4th structure. 4th one is 1,4-dibromo-bute-2-ene. So the parent is bute-2-ene. Parent is 4 carbon long and at the 2nd position double bond is there. So this is 4 carbon long parent chain. When you number it from left to right, 1, 2, 3 and 4. At 2nd position double bond is there. So I will place double bond between 2nd and 3rd carbon. And 1 position and 4 position occupied by bromine. So here bromine is bonded to 1st carbon and 4th carbon. Now balance the hydrogens. So here you will get CH2, CH, CH and CH2. So this is the structure of 1,4-dibromo-bute-2-ene. Now come to the 5th question. 1-bromo, 4-secondary butyl, 2-methyl benzene. Here this is the benzene ring in which alternate double and single bonds are there. At 1st position bromo is there. So here we can draw bromo. At 4th position, secondary butyl is there. At 4th position, if it is 1, this will be the 4th position. Secondary butyl means the carbon to which substituent is bonded to benzene ring is secondary. Secondary means which is bonded to other 2 alkyl groups. So here CH3 and as it is butyl, it should contain 4 carbon. So 1st carbon, 2nd carbon, this is 3rd carbon and this is 4th carbon. And the carbon to which substituent is bonded to benzene is secondary carbon. So this group is the secondary butyl. And at second position, methyl group is there. So this is the second position where CH3 group is there. So when you number it from here, 1, 2, 3 and 4, we will get 1 bromo, 2 methyl. And at fourth position, secondary butyl group is there.